Good morning, everyone. Thank you for joining us today. We're glad you are here. Before Ms. Pat takes the session control here, I'm just going to go over a few housekeeping items for you. First of all, we will be recording the session today, so your continued participation does provide your consent to be recorded. If you prefer not to be recorded, you may send us your questions directly using the chat feature or by emailing the session leads directly, and they'll get back to you with those answers as soon as they can. You'll find all of your WebEx controls on the bottom of your screen. Please use the chat window to engage during the session. We've got folks that have started introducing themselves there. Just share your name, your company, and where you're joining us from. You'll notice that you have been muted on entry. Please unmute yourself as you have questions that need to be asked verbally. We do ask that you ask questions in the chat window first, and then as we come to the end of each session, we will provide an opportunity for you all to unmute and ask questions verbally. Should you have any questions along the way, don't hesitate to reach out to me directly in that chat window. You'll notice that you can chat with everyone, or you can scroll down the list of names in the chat window and pick someone to directly send a message to. You can reach me right there. If you have questions, let me know. Otherwise, enjoy the session, and Pat, it's all yours.
Thanks, Robin. A very sincere welcome to all of you to our session on distribution grid model data management. It is one in a series of sessions that EPRI Europe is putting on this week. We call our series the European Workshop Week 2022. In this session, I am delighted to have a group of folks with me to share their perspectives on what I think is complex and vitally important topic of the management of grid model data. We're going to kind of cover these sorts of items in our session today. I'm going to give just a bit of background on why we think this is an important topic. Then we have Flo Silver and Alex Walmsley from Ofgem. That's the Great Britain regulator, here to talk about their perspective on the public sharing of distribution data and the importance of doing that in a form that's standard and electronically readable. Then we're going to switch gears a little bit. I'm going to talk about grid model management from sort of a utility industry view, really focusing then on what a utility can do to get a handle on and manage the grid model data that it owns inside the utility. And then we're going to hear from David Kirkland from Oracle, who's going to give a vendor perspective on the challenges, kind of the future possibilities that they see from their point of view, along with a little bit about some work that they are doing together with us in the GMDM Vendor Forum, an activity which is leading up to an interoperability event this summer. I'll see us out then with a wrap up, a few takeaways, some resources that are available, and some opportunities for engagement with EPRI. With that, if you look at a distribution utility and the entities with which it interacts, there are lots of drivers behind the need to share distribution data. And I think first and foremost among those is the fact that grid behavior, right, is just becoming more complex with the addition of embedded distributed energy resources. So that complex behavior needs to be understood so that appropriate decisions can be made. With those challenges, with the challenges of DER also come the opportunities of flexibility. So maximizing those is another driver for actually sharing grid model data. And I think it's also fair to say that it is the distribution utility that plays the kind of rubber meets the road role in allowing the electric sector to effectively deliver its potential in the climate change arena. there are lots of data exchanges that distribution utilities are being called on to execute. If you look up at the top there, the purple ones, the exchanges with other entities that are involved with running the grid are sort of the first obvious ones that come to mind. The need for T&D to share information. Markets as well, the participants that are engaged in those markets. And then if we look over on the left side, society as a whole could really benefit from information about the grid and can help encourage sort of disruptive and good change. The common requirement that all of these data sharing activities have in common is the need for a utility to effectively manage its own data inside of the utility itself, frankly, among the many applications that they have that are also producers and consumers of information. In this era of digital transformation, data centricity, it's important, I think, to recognize that there are many different sorts of data that it is really important for utilities to manage well and at an enterprise level. And frankly, grid model data is just one more of those. But I would kind of put out there that I think that grid model data is unique, both in how fundamentally important it is and in how complex and difficult it is to manage. It's probably the right moment to talk about what I mean when I say grid model data. And in my book, grid model data is something that is representing a functional view of the electrical grid, and it comes in two parts. One part has to do with the physical part, the equipment, its electrical behavior, its connectivity. And then the second part is a snapshot of the grid in a particular operating state. If you combine those two together, both the physical and the operating state, both of which I consider grid model data, put them together, and those together should make an effective or an appropriate starting point for a power flow based grid simulation. So that's what I mean when I say grid model data. Looking again at the distribution utility sort of data sharing picture, it's pretty obvious that there's all sorts of perspectives that could be taken in looking at the problem and looking at solutions. And today in our session, we're going to be hearing from three of them. Ofgem is going to be covering more of the sort of external data, external sharing of grid model data. I'll be taking a look at the management or sharing of grid model data inside the utility, and then Oracle will be giving us the vendor perspective on the picture of shared grid model data. With that, let me switch over to Ofgem, who are going to share the regulator's point of view with you.
Okay, morning folks. Hopefully this is all coming through and you can see me still. Perhaps not. So I may need an assistance just to help me get the camera back on, I'm afraid. Where is the
That's right. Yeah.
Super. Thank you very much. Okay, so pleasure to be here this morning, talking to you and folks from around the world. So my name is Alex Walmsley. I'm here with my colleague as well, Flo Silver. Now, what I want to talk about this morning is how, as a regulator, we're engaging in this work, how we are going from a kind of interest in data to more of a proactive and attempting to kind of stimulate some of the required data sharing as we see it. But I suppose just as a kind of top level, I have to explain, I'm not a data expert. I'm not a technical engineer. I work in policy, and I was attempting to explain this to colleagues last night, and essentially saying, as a job, what I do is I try to bring together some of the technical parts for policy people and policy parts for technical people. And so this is what's probably quite novel about the work that we're doing as the GB regulator, attempting to kind of go beyond data sharing is good, digitalization is good, let's get to net zero, kind of top level strategic ideas, to some of the more granular ideas around data sharing and how to actually start to realize that in very tangible and realizable ways. So that's why we've become involved in this work. Hopefully the kind of regulator's story will be interesting and give you a bit of an approach as to how we're thinking about these problems. So I'm going to go through, I'm going to take the first part, sort of giving our role, the problems around data and regulation. Like all good stories, it has a beginning, a middle, and an end. Flo is going to take us through some of the detailed work which we're doing and some of the reforms which we're leading on and setting up for industry, before kind of broadening out to how does this fit into our wider approach? Where is this work going? So realizing that we have folks from all over the world. A quick note on terminology. In GB, we call our distributed networks distribution network operators. This will be the term normally referred to as DSO. In Europe, for us, DSO is the actual role around system operation, which is a new and developing area of policy, an area of expertise. As it stands at the moment, our DNOs, as we call them, are largely the pipes and wires networks, starting to do some system operation, but not sort of system operators in the same way that we talk about our ESO. The next line here, the electricity system operator. That's our national grid, our group. The LTDS, so long-term development statement, is a specific reform on which we are leading some of the changes, leading some of the policy work, and DER, distribution energy resources connected to distribution networks. So to get through, we have this problem, right? So we have this problem. We think that for our role as regulator, for essentially ensuring that network users have the best deal going, receive are protected as consumers, and that the energy network works for people. We have this core problem around data sharing. We expect that more and more data needs to be shared in a usable fashion, as in standardized, to enable innovators, flexibility providers, distributed generation to make more informed decisions. And we see at the moment, or historically at least, there has been this issue around getting data available. Our distribution networks are historically engineering firms, not tech firms. And so we're going into this kind of, how do we make sure and stimulate data sharing for the public good, I suppose. That's our kind of our raison d'etre for engaging in this work. So we looked and we saw, okay, so the volume and complexity of data required to receive some of these benefits is going to only increase and increase at an incredible rate. So we started looking and saying, data sharing, okay, so there is a thing called the Common Information Model, and we've swatted up an awful lot over the last few years to understand this at a functional level, and basically saying, look, so there's this thing, right? There's this thing called the Common Information Model, and we want data to be able to be shared. Let's make it happen, okay? Let's move this forward. So we did our research and we could see that there were areas where it was being used, but it wasn't happening in a necessarily a coordinated fashion. It wasn't necessarily happening in a way where it was necessarily fast enough for our appetite. And so we wanted to sort of make sure that there wasn't too much divergence. And so this is where we've started working with EPRI and with Pat to make sure that the work going forward takes on that kind of coordinated making as much value from data as we can. So that's the problem. We could see there was some maturity of solution, but that it wasn't necessarily being delivered in a coordinated fashion. Hence the regulator has become engaged in this work. Now, that's quite a specific thing for us to be doing. So this is kind of novel for a regulator to be this involved in something quite technical. Normally it's the high level, but these kind of chevrons, I suppose, taking, apologies for more and more different acronyms. If anyone has a specific question on them, obviously shout and we can fill you in. But for now, the idea here is that there's a tip of a tip of a tip, and that by getting some of the data sharing foundations in place, we can start to make sure that further sequential data sharing is built on that in a manageable and forward-looking, sensible way. So overarching aims: data can be used, it's a strategic asset, data is visible, data exchanges work. Our priority to consumers, essentially to kind of stimulate this and make sure it plays forward. Okay, so as I was saying, we looked around, said, okay, so SIM is essentially the de facto energy data standard. It's already been used in parts of the industry. If it's all going to go ahead, why does your regulator care? Can't we just sort of step back, get out of the road, let everyone else get on? Now, the problem with that, as I was pointing out, is that we want to ensure there's sufficient coordination and timely delivery. Hence why we've picked up this project, the LTDS, which Flo will take us through, actually defining and extending some of the standard where it's necessary. There are parts which will require bespoke extensions for the GB network, but there's a wider coordination piece with our IEC colleagues, with colleagues across this call, who I'm sure are familiar with the international coordination around the SIM, and Flo is going to take us through some of the wider kind of governance arrangements around that as well. So we saw this issue. As any good regulator, we consult. We went and we found out, and we saw there was enormous appetite for this as well. So it wasn't a kind of, we think this is an issue, we're going to dive in. We consulted, there's enormous appetite for data in general from network users, from flexibility providers in the industry. Going beyond that and saying, okay, well, what about this specific bit of data? And people came back and said, yes, absolutely. Start somewhere, start the ball rolling. Please, can we have this long-term development data, statement planning data, so that they can inform network decisions? Please make that in a usable format. From there, we can do other things. So this is one part of the puzzle, but it for us is a starting point to help our future coordination of data. So I'm going to hand on to Flo, who's going to take us through the specific parts on the LTDS and the governance as discussed. Thank you.
Okay, good morning, everyone. So I'm going to run through, as Alex has been mentioning, the long-term development statement, which I'm going to end up referring to as the LTDS. I'm sorry to introduce another acronym, but that is what I'm used to calling it. So the long-term development statement was designed to share planning data. The idea is that the networks would publish this data, and third parties looking to connect to the network would be able to do some of their own analysis and figure out where the best opportunities were to connect. Now that we've got a lot of changes happening in how people provide services to the grid, people are starting to try and use this information to see what other services they could provide beyond just simply connecting the next piece of generation. So it's a high importance piece of work, but there are some problems with it. It's currently shared on Microsoft Excel. The spreadsheet was designed about 11 years ago. It hasn't been updated since, and it's quite inaccessible. But it's providing people with a view out to the next 5 years on the network, plan changes on the network, kind of high certainty changes. And it's published annually by each of our DNOs. So to update this, Alex mentioned we did a consultation. We got back a lot of interest in updating the LTDS, making sure that it was going to be able to provide the information that people are starting to need. And we were thinking about how to try and make sure that this would both be a feasible change to make, but that it would also meet the needs of people, of users. And we decided we would set up a working group, and that working group would be comprised of both the data owners, so primarily the DNOs, but also the people who are looking to actually use this, and that we would maintain chairship to kind of try and make sure that the views of both sides of that working group were heard. And the working group will look to define a scope for what we refer to as the form of statement, so the kind of the model, the information, and the data that need to be included in this future version of a long-term development statement, and that to make sure that that form of statement, that information in the future isn't in an Excel spreadsheet that can't really capture all of the detail that we need about this new and much more complex system. We started looking at what the best way of presenting that information would be, and it became very obvious very quickly that the common information model would be the best way of doing that. So we have a delivery partner, so Open Grid Systems, EPRI. We're very lucky to have Pat with us on that delivery partner, and Grid Digit with Chavdar. So that gives us some really serious SIM expertise, who are going to be taking that scope from the working group and converting it into the common information model. So just quickly for people to have a look at, so we've got here, this is literally a screen grab from the current LTDS. So that is the kind of table of information, and it's mandated that the DNOs fill it in that format. Makes it comparable, but doesn't obviously provide a great deal of information, and as I say, is very outdated. Moving through to something that obviously has a lot more kind of data information and attributes on it. So something that can kind of really support people being able to do more of their own analysis and understand what's going on with the grid. Obviously, this project that we are doing, we don't want to end up with a GB SIM model that is completely unrelated to or is diverged from what's happening in the IEC. So the idea is that we have international SIM experts in the delivery partner. This work will go through the IEC committees. So we will hopefully end up with an option for sort of GB SIM governance, and we have some options there that we've considered. We have the electricity system operator in the UK. We have something called the Energy Networks Association. There are also discussions around a future system operator, or essentially an ISO. And there is also an existing kind of mirror committee in the BSI. So we have some options. Some of those options seem better to us than others. But what we're really keen for is that whatever we set up for kind of SIM governance in GB, it will be made up of not only the data owners, but also vendors and users will have an opportunity to input into that forum, but that it will sit underneath the IEC, and that work that comes through that group will be fed up and be included into future iterations of the SIM standards. So just as a kind of an idea on the timelines of the work that we're doing with the LTDS, we have begun, the delivery partner have done some work kind of comparing what's in the LTDS existing to what's in the SIM standards to see where we've got gaps, and we might need to create some extensions to be able to describe the GB system specifically. And then starting to look at actually draw out that list as we add additional attributes to the LTDS. Looking to kind of have a full scope for the LTDS nailed down at the beginning of next year, which would then mean that could be kind of fully converted into the common information model, and we would begin the kind of regulator side of things consultations into the beginning or the Q2 of next year. So just in terms of, I guess, bringing it back out, as Alex mentioned, to how this all kind of fits together, we see the long-term development statement project really setting out that SIM is the way in GB. It provides people with regulatory certainty that this is the route that we're going down. Helps to like make sure that we've removed the risk of fragmentation, pushes the DNOs to improve their data management. And it will also make sure that third parties will have access to detailed network information. We see it as being something this will build. So if people have had to get themselves able to do this project in SIM, then further applications of the SIM become progressively easier each time, and that all of this together drives through to consumer benefits. And this also leads us to some of the future kind of projects that have been discussed. So better digitalization of the energy system, leading to things like digital twins potentially being built on the common information model, digital spying concepts using this kind of setup as a way to make sure that information is interoperable and exchangeable, and that this will essentially drive markets having a better access to data. So that is the end of the direct presentation. If anyone has questions.
There is a question in chat.
There is indeed.
And I'm in the chair.
There is a question which says it's from Danny Blah, saying in Europe is the GDPR regulation, does Ofgem have some regulation like that in mind as well regarding consumer data sharing in general? Now, I mean, I'm happy to take that from, you can hear me talking here. So GDPR is carried over pre-Brexit for GB. There is a kind of move towards making a GB specific GDPR, but I think that it's largely going to be, in theory, a similar set of consumer protections. Now, in terms of consumer data specifically, one of the more apt examples is around smart meter data sharing. We have a system in GB where smart meter data, if it's to be used for grid management, needs to be sufficiently aggregated and anonymized to essentially delimit the risk of individuals being identifiable. Now, all of the DNOs have published on their websites and on our websites their plans, their mechanisms, their IT infrastructure required to do sufficient aggregation and pseudonymization to kind of meet that threshold. In terms of, and essentially that's been signed off for use so that they can access things like smart meter data. Wider kind of data sharing rules and regulations also fall under our Centre for Protection of Critical National Infrastructure, who we're working closely with to make sure if the DNOs are sharing data, that that's not also posing new risks and threats, whether they're cyber or physical. And so these things are being deeply managed and considered as well. So risks, yes, but benefits to be had by taking a considered approach.
I think it's also worth noting that for this project at this point, we're looking to extend, so the LTDS currently covers the 132 and the 33 kV networks, and we are looking to extend that down to the 11 kV, which is already a fairly ambitious goal in terms of the data that DNOs have and will be able to put into the models, which doesn't take us down into data that is typically covered by GDPR, that doesn't meet the kind of criteria for being personal data. So we do see that there will be, the more information you share in the future, the more that ensuring that you are protecting people's personal data is important. But for this project directly, it's not expected to have significant impact because we are not looking at the moment of pushing this down to LVR, LV and kind of consumer level.
Great. Are there any other questions for Flo and Alex? If there are, please feel free to put them in chat.
Okay, question coming through from Miriam. Thank you for taking on this initiative. Are you able to share why CGMES was chosen over CDPSM?
Wow, for that question, I mean, yes, but we do have Pat here, who is part of our delivery partner, who was one of the ones who advised us of the suitability of CGMES version 3. So,
okay, so the first thing I guess I would like to note is that they're enormously similar. Both of those standards are essentially profiling standards, and they rely on the same underlying canonical information model. So the differences between them are, I don't know what I would say, small, specific, tailored to the particular use that a given data exchange is serving, or the purpose that it's serving. And so I think that, frankly, what we will end up with in the LTDS work is something that starts with CGMES, but ends up considering some of what the CDPSM set of profiles has in it. For those who don't know, CDPSM is a collection of profiles that are tailored to the exchange of distribution grid model data. And to just be completely honest with you, having lived in this world for the last few years here, that CDPSM standard is not so standard. We have some conflicts in the descriptions of those profiles that I would say make it just kind of out of the gate a less suitable starting point. But I think more importantly, from the perspective of kind of reality, is that CGMES, which is the exchange standard that ENTSO-E has published for its exchanges of transmission level information, that is a profile that has been implemented by multiple vendor tools. And so there's close to off-the-shelf support for CGMES data exchange. So that just seemed like a logical place to start because of the commercial support for it. I do anticipate that we're going to be identifying some places where it needs to be extended, and those could very well be the sorts of pieces of data that CDPSM covers. I hope that made sense.
I think that's really helpful. I think that's hopefully covered Miriam's question there. Okay, got a great thank you. So Karen is asking, do most DNOs have DMS systems that can already export SIM format models, or would they come from your planning teams, e.g. PSSE, Power Factory, etc.? So, I mean, I can make a start on that and then anyone else can jump in. There was a piece of analysis from the ENA, so as Flo mentioned earlier, the Energy Networks Association, which covers all of the DNOs, to essentially kind of do a bit of a stock check on their capabilities to currently export and what software packages they were using. There were some capabilities, but fairly variable based on essentially how the DNOs had worked with different vendors and made bespoke items over time. There were also instances where, so for example, WPD, the largest geographical area DNO in GB, has started sharing some SIM models, but they're not in CGMES version 3, and they're not covering all items, and the bespoke extensions are not consistent. So there is some work in this, but it's the actual kind of de facto data sharing as it happens at the moment is still essentially flat data tables, whether it's to the public. We are also aware that most of the DNOs share data to the ESO in an Excel format. The ESO then converts it into SIM, uses it in SIM, and then converts it back into Excel to share back to the DNOs. Now that doesn't seem particularly efficient, so there is a need for this to be upped and standardized essentially. But if anyone else wants to jump in on that as well.
Can generally summarize that what Alex is saying is no, most of them can't. There are some DNOs that have done a bit more in getting themselves into a better position with SIM. The one thing that is coming is that in GB next year, beginning of pretty much this time next year, we will start the Rio ED2 price control. and in the business plans that have been submitted for the price controls, all of the DNOs have put significant spending against IT infrastructure, and particularly in adoption of the common information model. So there is allocated funding against it, but it's not something that they have the capabilities to do now.
Okay, so follow-up question from Karen. Is anybody splicing the network models together? And if so, how do you manage consistent MRIDs, global unique IDs for each organization, so that incremental updates can be reapplied to the combined network?
Where is Alan McMorran when you want him?
Sorry, it's David Kirkland from Oracle. I am speaking later, and I will touch on that point about the update of the model, how that process flows, because we're one of the vendors that's been involved in the GMDM project. So I will actually pick that point up later. So stay on until later in the session, and I will talk about how we keep those models in sync.
Perfect.
Excellent. I think we're probably at time to change back to that. So that's okay. We'll move on to the next session on grid model data management.
All right. So now we're going to kind of shift gears a little bit and focus, instead of on external data sharing, on data sharing inside the distribution utility. So this notion of effectively managing all of that grid model data that utilities have inside themselves and use inside themselves is something that EPRI has been looking at for, I fear to say, about a decade now. And it is the exact sort of work that addresses that question that Karen just asked about how you manage effectively pieces of information with identifiers that are coming from different places. So, and I think personally that getting the data management right inside the utility is kind of key to being able to easily satisfy the kind of data sharing requirements that Flo and Alex were talking about. So just wanted to go through a brief kind of history of what EPRI has done in the area of grid model data management. Back in, it was about 2012, we started out looking at the question in the transmission domain and worked with several utilities, produced a report that talked about how the common information model could actually help with network analysis data management. We worked with a collection of vendors and utilities, I think maybe we had about 9 of them, to actually define the requirements that a network model management tool ought to be able to meet in the transmission domain. Over the course of our work with the transmission utilities, which kind of continues to this day, I think we've probably sort of done deep dives with maybe 10 utilities or so, something like that. Along about 5 years ago, we realized, though, that probably what we learned in transmission had the potential of being really useful in distribution. So we launched a collaborative project. We have had 12 utilities that have been working with us. They are predominantly from the US, but also Canada, Ireland, and Thailand. So we've looked at existing grid model data management practice at those utilities. We can really try to understand requirements, their challenges, try to get sort of an industry view of the picture of grid model data inside the distribution utility. And out of that work came an approach. We call it our grid model management information architecture, but it's an industry level way of organizing and thinking about how you manage grid model data inside the distribution utility. So whether you're talking T or talking D. The situation is complex in part because you have lots of consumers or studies for which grid model data is needed. And those consumers can be inside and outside of the utility both. But the universal thing that is true about those consumers is they're very picky about what they want. Each of those consumers has its own view of what it needs in terms of a network model. Different consumers want different grid extents. They want different kinds of data. I'm doing a short circuit study. I need zero sequence impedance, whatever. It's different sorts of data, different levels of detail, and probably most crucially, different studies are being executed for different points in times, and the representations need to be for those moments in time. Grid model data also has, at the typical utility, T or D, many sources from which it actually comes. So it's a situation where you have lots of consumers who have differing requirements about what they need to receive, and then multiple providers of information that needs to be put together in order to create the data that is shared with the consumers. And what makes it even trickier, because it's grid model data, is that the information that is assembled together from sources, in order to be useful to those consumers, needs to be electrically logical. It needs to be a valid starting point for power flow. So requirements that are shared among T and D are here. If you look at sort of the solution to meeting those requirements that has been the foundational part of our work on grid model management, it's the same in T and D as well, in the sense that in both of those environments, there are multiple suppliers sort of tangled, inconsistently triggered, duplicative information flows between the sources and the consumers. And this is the kind of situation that in both T and D means that you have duplicate data running around. You probably are doing redundant processing, and sometimes it's even happening within the transfers itself. And ultimately, of course, the price that you pay is inconsistent models. So in both T and D, our view has been, or our vision has been, to take that and turn it into a picture that looked a lot more like this, where you actually have a coordinated managing of grid model data so that you can easily understand where the of record source is for any piece and kind of where it goes in terms of its arrival at other applications as well. So requirements are kind of the same. The solution vision is sort of the same, but T and D are really different in nature. In transmission, folks have been doing network analysis for decades. That network analysis has ended up being in some very common silos. There's a planning silo, often a protection silo, an EMS silo, maybe an outage scheduling silo or a market silo. So in each of those silos, people are manually maintaining grid models, and folks in transmission can sort of see what the problem is. They know what data they need because they've been doing this for decades. They see the manual duplication of effort, and it's real easy to say, look, if you just put some kind of grid model management, network model management tool or function in the middle there, you could be entering it once and using it 3 or 4 times. So transmission conceptually is kind of an easy environment. Distribution doesn't have any of those characteristics I just rattled off. People are not necessarily familiar enough yet with the requirements around grid simulations, power flow based grid simulations, to really understand what data they need. There is no uniformity in terms of the landscape of applications that are used or how they are used. And as opposed to people having a perception that maybe manual entry is the issue, not so in distribution, because much has already been automated in distribution. The issue is that it has been automated with brittle point-to-point interfaces, but it's easy to think that the thing you need to do is just make those interfaces less brittle and not sort of rethink the way that you're managing data altogether. So T&D are quite different. And those differences have made it so that in distribution, the use of a business function approach to defining our information architecture is just really critical. It's critical in framing the conversation, in understanding the problem, in developing the solutions. And as we have worked through this, it really has ended up being kind of a universal language that lets us talk to most any utility about their situation and ways to improve it in using a tool that's nice and universal and generic. So this slide is just a quick illustration of kind of the graphical representation conventions we have used. We have founded our architecture or are expressing our architecture in a language called Archimate. And so much of what you're seeing here is a reflection of Archimate conventions. Business functions, which are sets of behaviors or activities that in our case are going on within a utility that deliver some kind of essential business outcome. They are expressed in rectangles with rounded corners on them. Business functions can be subdivided into subfunctions. And when we do that, in our case, we're making the color of the subfunction darker. The other kind of artifact or construct that we use in our information architecture is this notion of business objects. And they aren't objects in the data IT, in the IT-ish sense. They are sort of chunks of related data, let's say. And business objects are expressed in those rectangles with sharp corners on them that have a line through them. The key thing about functions and objects is that in the information architecture, business functions are seen as being responsible for a business object. So they are and the function is the thing that creates or modifies or updates the object. So to look at our world, what you're seeing in the background here is a picture of all of the business functions or sub-functions that we thought were relevant to grid model data. And I realize this is a complete eye chart and there's no way you can actually read it, but this is just to kind of give you an idea of maybe the complexity of the model. And it's an opportunity as well for me to say that the information architecture and its business functions are very grid myopic, right? We are about grid model data. And so business functions, if they appear here, are ones that in some way source or modify or mangle or consume grid model information. And unabashedly so, right? The purpose of this is to help us understand grid model data and how it should be handled. In our information architecture with our business functions, we noticed early on that there were business functions that were of a couple different natures. One set of business functions, and they are shown below in purple here, are business functions that we call facilities-oriented ones. They are business functions whose main activities focus on grid components, on a switchgear in a substation. It's design, it's installation, it's maintenance. So these tend to be business functions that are supported by software like engineering design tools or GIS or asset or work management systems. And one of the important realizations about grid model data is that kind of in the end, all of the physical part of grid modeling actually originates in these facilities-related business functions. There's another collection of business functions, the ones that we've colored in blue, whose purview tends to be the behavior of the grid writ large. So we care about how all those components that the facilities folks are managing actually work together. And typically it is those business functions that actually have the applications that are consumers of grid model data in them. There's some places where it's supply, but typically it's consumers. And the sorts of software we're talking about there are distribution management systems or planning or analysis kind of tools, maybe market systems. To kind of finish off our coloring picture here, we have implemented a coloring scheme for our business objects just to make it so it's a little bit clearer which ones are truly grid modeling versus other kinds of business objects. And we have three main sorts of business objects when we are talking about grid model data. And one is essentially a collection of objects that represent a portion of the grid, kind of a snapshot. So those are our business, our model business objects, and they're in pink. Then we have our model update business objects, and they just talk about modifies, adds, deletes of those grid model business objects. And then lastly, because this is grid model data, we have a kind of business object that collects together those model snapshots that actually then are suitable grid modeling to hand to a consumer. Lastly, we have other business objects that we colored in yellow. So here's the overall layout of the business functions. And that's kind of the level of detail or the complexity to which the business objects are defined. I know this is an eye chart. I'm not showing this to you so we can digest every corner of it, but just rather to give you an idea of kind of the scope of the information architecture. And it's also kind of a backdrop against which you can sort of see most of the grid model data comes from facilities, business functions that give you updates to the grid model. There's a few updates that can come from the business functions that are more system oriented. And then the consumers of assembled models tend to be those applications that are serving the business functions that have the system orientation. In that eye chart, in the middle is a business function that we call grid model management. And we think it's a vitally important business function to call out. I've said here it's new. I think it's new in the recognition only. It doesn't, it isn't a brand new thing in the sense of it's never been done before. We do it all over the place. The problem is that we don't do it in a coordinated fashion. So it seemed like, in this work, it was an important thing to look at kind of the cohesive way that grid model data could be managed instead of the way that it often is now in a very sort of fragmented way. So let's take a look at that grid model management business function and what it's made up of. It has a couple of sub-functions. One of them is master grid modeling, and that business function comprises all of the activities that track sort of the single source of truth information for a utility. And it's master level information. And by master, I just mean the most detailed level that is required in order to derive the modeling that any application needs. Master grid modeling has a couple of subfunctions underneath it. So essentially there is some kind of activity that captures changes or updates to the currently existing master model. And that function basically is managing future change descriptions from from the time that they would be approved, useful to anybody in the utility organization, clear from that moment until the moment that they actually are commissioned and incorporated into a new version of the as-built. Just want to make a quick note here that at least in our world, the notion of an update or a project is very much an individual granular thing. It is a proposed possible change that might need to be added to an infinite variety of future models that are used in future studies. So the idea of there being a business object that is the update object is really a crucial one. The other subfunction inside of master grid modeling is master model version creation. And it is indeed the function that takes those commissioned or ready to roll updates to the grid and uses them to update the existing as-built and to create a new version of it. And I think it's important to note in this vision here that every single change to a grid model is viewed as a model update. It's, even if it's just a correction, it's still modeled as an update. It has an identity and it's added into an as-built. The other major sub-function inside grid model management is assembly support. And assembly support is made up of a collection of services that make that master modeling ready for consumption by the various applications that need it. So typical sorts of things that it might do are simplifying models. It might be adding future projects to create a model for a particular future moment in time, or a particular combination of projects that need to be studied. After that is done, it might be doing operating limits calculation, might be adding on load and generation, and it might be putting grid models from different portions of the grid together in order to pull a case together for a consumer. So with that, that's kind of the overview of the business function core of our GMM information architecture. And we are like right at the top of the hour. So why don't I give you guys 5 minutes to grab a cup of tea, a cup of coffee, and we'll see you back at 5 after.
Got a few questions coming through on the chat. Thank you. I think we'll take a few minutes for questions just now. Is that right?
Well,
Did you want to carry on?
why don't we go ahead and get done with the little final part of the grid model management piece and then do it? All right. So what I've talked about so far is, conceptual and industry design oriented, and I've not said a word about data exchange or the common information model. And I think it's really important to note that not only does the common information model support this, architecture that we are looking at and advocating for, but it really has grown out of understanding that the SIM has allowed us to develop about grid model data itself. So those 3 grid model related business objects are supported by SIM classes. They are supported by SIM classes that literally the working groups have been speaking about and arguing over for probably 5 years, but that will finally be going into SIM version 18. So the model business object has a corresponding model class in SIM. The model update business object will have a change model class in the SIM, and assemblies are sort of self-explanatory, right? There's an assembly object that is a collection of multiple of those model objects. Those classes are called meta classes, not my favorite label, but it's the one that's used because it's kind of data about data. And the about data is then the grid model objects with which we are all much more familiar. So the classic SIM, conducting equipment, terminals, connectivity node kind of information, those grid objects are organized by the objects that are of the meta classes. So for example, when we talked about the model business object being a snapshot of a grid representation, well, in the SIM, there's a model object, and indeed it contains a set of instances of SIM grid classes with, you know, in a particular state, right, with particular values on particular attributes and specific associations and all that sort of thing. So that's what a model has in it, is a snapshot of the grid in terms of grid objects. And then a change model is nothing but a set of add, modifies, and deletes to specific grid objects. So the SIM is very much kind of part and parcel of this information architecture. And I just thought it might be useful to take a quick little spin around sort of the usual progression of a grid change and how the SIM meta objects would facilitate it in this business function architecture here. So typically, right, if it's a big grid change, it's likely to originate in planning. Planning could express that in terms of a change model that would go over to the master update management business subfunction, which again would maintain it in terms of being a change model. As that project progresses through its life cycle, it gets engineered, it gets built, it gets commissioned. Changes can come from other business functions, facilities design or records management, maybe even from grid operations. And at the point that it actually is made live, then the change model would be incorporated into the current version of the as-built model by the as-built model master version creation business subfunction. And that just goes on. That activity, the master grid modeling activity, is running all the time. It is not triggered by anything other than grid related activity or updates, correction updates to the model, but it's an ongoing process that's continual. When the other assembly support business function is one that's triggered by the needs of consumers. When a consumer needs a model, then the assembly support business function is the set of activities that use those change models and probably the current version of the as-built to actually pull together the modeling that a given consumer needs. It would be expressed in terms of models and assemblies and shipped out to the applications that support those various other business functions. So just kind of the SIM is such an underlying integral part of this information architecture, and I wanted to kind of tie that together for you. So everything I've talked about so far is about an industry approach to this management of grid model data. And, you know, there is a reason that we talk in terms of industry. It is an industry issue. We think it has an industry solution. And the reason that it needs to have an industry solution goes something along the lines of the fact that T or D, we are a cost-conscious industry, and we tend to rely on vendors for our integration solutions. That's just how we do it. We are buy, not build for the most part. The problem with that is that vendors don't see an enterprise view of the utility. The only people that have a view of data across the entirety of the utility is the utility itself. Even one utility, however, that is doing a really good job of trying to manage their information, they have taken on the responsibility. They're going to design a really good enterprise-wide solution. And they're going to engage all of their vendors. We're talking 5 or 10 vendors here, not just 1 or 2. We're going to engage all of our vendors to help us implement it. The problem is you're still going to end up with a one-off solution if no other utility uses it. And that one-off solution is going to have all of the same kind of costs associated with it as any other one-off would. So that combination of things, we buy, we don't build, the fact that we need to get every one of the vendors that are playing in our utility sandbox to work together sort of ends up meaning that the real way we'd like to see things done is that a collection of utilities agree on a solution approach, that they speak in one voice to the vendor community saying, look, here's a way we would like things done. Here's a framework of data sharing that is something you can implement a standard interface for and sell it over and over again. And I think that's the point at which utilities get the interoperability they need at a cost that is reasonable. So that's kind of my messaging on our inside the utility data exchange. And yeah, if we've got questions, what do we have here?
We certainly have some questions coming through. I think
Let's see. Can we take like 5 minutes, Flo, for questions? Okay. All right.
Okay, so we've got some questions coming through. Thank you for posting those on the chat there. We're going to start with one about data and integrity and consistency, because I think that's on nicely. So that's from Danny again. How is the topic of data integrity and consistency being dealt with? Is it a separate overall function?
Well, there's multiple angles to that. So the out of the gate answer is that the way you ensure correctness, integrity, is by implementing an architecture that gives you a single source of truth. That it's not saying you have one application that's a single source of truth. It's just saying for one piece of data, you can point to the application that's really responsible for it. And so you have a solution designed for sharing that data that makes sense. And you have the business processes underneath it that enforce, is probably the right word, enforce the fact that if that piece of data needs to change, it's changed at the source of truth. So I think that, kind of the foundational thing is you need to have a design that respects the single source of truth. You need the business processes that support it. But in addition to that, with grid model data, there is, it's that business about you need electrical integrity and electrical cohesiveness. So obviously that there is more to it for grid model data than just getting the single source of truth stuff right. You need to make sure that what you put together works as well. So validation is a really important activity that I think is part of the whole grid model management kind of business function. We've done a lot of looking at this. There's all sorts of things to consider about, did you end up with overlapping projects or not? Is this model that you're going to build actually something that's viable? And so I think an ongoing process of model building and validation is just an utterly essential part of actually getting data right when it moves to the consumer. Does that make sense? I hope.
I think that sounds very sensible. We have another separate question here from Boniface Chai, who is asking about generated models. So the question reads, does the grid model data management include a generated model? And how do you manage this, particularly on user-written model generators? So a tricky one.
I think he's been talking to Karen. from AMO, who has a magnificent challenge with managing their dynamics generator models. This is a problem that is obviously growing in importance with the increase in inverter-based resources, the number of them, where they're located in the grid, the transient subcycle behavior of these, it becomes just very much more of concern. And you know what I think, and I will give huge credit to AMO. We're learning just a massive amount as we work with them. You know, I think that grid models are a beast that is, you know, okay, let me just say, the way that we can manage grid models, dynamics models right now is, yeah, we can be real clear about what generator, what location in the grid they are associated with. Obviously, we can support that. If you are willing to leverage much more standard models, either standard vendor models or IEEE, IEC kind of standard models, the SIM itself supports the exchange of the parameters for those models. But you realize that that's not, in the eyes of many utilities, sufficient for them to really understand their grid behavior. They want the kind of models that generator owners or OEMs are wanting to hold proprietary. So, you know, I think that, you know, as you look at those, it's a situation where you have multiple models, often for different software packages, that need to be selected to apply to a generator at a certain point in the grid. And what I am guessing our earliest efforts in managing that kind of data will actually look like is sort of treating those different models, especially the proprietary ones, as kind of white blobs. They're a DLL, maybe they have an accompanying even picture with them, but they're a set of data that you can use and say it applies at this location in the grid. So it's a major challenge, clearly.
Now, Pat, I've just seen, as we're going through, a couple of folks who have come off mute briefly, so I don't know if anyone else wanted to come in on that and raise any additional points. I think Karen
would be one.
Karen and David have both momentarily come off mute, I can see. So
Yeah.
anyone else wants to jump in, please do.
I just came off mute to have a giggle at Pat. Yeah, we're actually busy building a system for to make the power system studies available with dynamic models, but the compiled versions, so that we can protect the confidentiality of the wind farms models, especially. And sort of we would be running that mostly PSCAD sort of studies on the cloud. But that's transmission level with only a small little bit of distribution included. So it doesn't help you, but the concept is the same. But to make things simpler, or maybe something that's doable for most people, if you can get your hands on some PMU data, high-speed data that's maybe 20 millisecond resolution, somewhere near the that's on your network that's near enough. What we're doing is to take our own edited models at the moment for DER, and validating them against the plots, like literally plotting the results together with the actual PMU data, the historical data, to see if it's working. So that we can feel confident. So we feed several fault time periods through it and can see how well the models actually simulate what really happens on the power system. I hope that helps.
Thank you, Karen. I think we are having audio issues here. I guess I would ask people, am I coming through clearly or not?
We can hear you clearly, Pat. Yeah.
Okay, so we are, everybody is garbled on the way into us, but apparently you guys can hear us. I think we're gonna be making an effort here to switch over to a phone connection, but why don't we keep going then? I think given timing, I would like to just move ahead to Oracle's presentation, and we will fuss with our audio issues on this end.
Okay, good morning, everybody, and thanks for the opportunity to share this morning. Thanks to Pat and the ECRI team who've been involved. We've been involved with this project. I'm not completely sure from day one, but it seems a long time since we became involved in the grid data model management. Just like to outline sort of our thoughts about where this will take us. The sort of thing I want to talk about today are really around the future grid requirements, why we need this data model, why it's not just a theoretical exercise. Some of the challenges we've seen and continue to see with different customers, how they're approaching data management. Some of the questions that come in the chat today about validating the data, ensuring its accuracy, where do you master the data, how the grid model is enabling the net zero, why this is really important in terms of delivering the targets, and to support what Alex and Flo were saying earlier about that ability to have interoperability between different vendors and different systems, and opening the grid model information up to a wider set of users in the community. Just to give an example of where we've used the forum, where we're actually working with a couple of network operators, and then a shout out, I think is the correct term, to an event that's running in June, where we're going to do a full interoperability test, and people are invited to attend that and see this theoretical data flow and data exchange all flowing through the model. So for this morning, just look at the requirements, starting really out with the sort of user requirements for the model. If I can get my screen to work. Well, we tend to look at, we work with a lot of operational activity. So we start with the operational. One of the bigger challenges we're seeing at the moment is the ability to integrate distributed energy resource management. How you do that at all voltage levels. Obviously, we've got medium voltage connections, we've got connecting up at the transmission level, but we're seeing more and more activity with connections down at the lower voltages, at residential levels in properties. How do you do planning for the network? How do you plan design the network, plan the network, how you do your outages, how you do protection settings? We're seeing a lot of requirements now for much better detail in particularly on the distribution network, the modeling required to support protection settings, with a lot of in-feed from inverters. Does the traditional protection settings work? We know of a number of incidents where the inverter has worked against the protection, and incidents have escalated. How we get a more autonomous grid? Do we need to centralize everything? Traditionally, we've come from a world of a centralized control platform, and we're now moving more to more autonomy, get more of the intelligence at the grid edge. I'll talk about that, obviously. But the big one is interoperability. And to the point that I think the colleagues from Ofgem were making, this is about opening up the platform, opening up the data to all the people that need it. A lot of projects have been done in the past where we've had point-to-point solutions. ICCP is great. It does a really good, secure job. But in the future, when we have a lot more interaction between the transmission operator, between the distribution operator, as that distribution system operator model matures and more activities taking place at the distribution, you need interoperability between systems, and not just within the same vendor. If they brought a system from Oracle and they wanted to talk to a system for another vendor, that interoperability has to be there, and you get that by using the SIM and an agreed definition of this grid data model management. I mean, Pat talked about digital twins, single version of the truth. I'll talk about that in the next couple of slides. Our approach to that, how we use digital twins to validate your market entry, how we use digital twins to validate how people are bidding in. If they're bidding a particular device, is it a valid bid against the type of device? And we're using standard models for that initially. We're using IEEE modeling, but we have the capability as we see the performance in real time to update those models using analytics and real-time information. All of which feeds into situational awareness and giving the control room the information that they need to operate the grid securely, but also giving the planners the latest, best information that they need to plan the system, to plan outages, to optimize how they provide connection offers to new connectees, or take planned maintenance outages when it's least disruptive to the market operation and all these DER devices that are connecting. So when we see success, we'll see this interaction between the different components. So it's not just a specification, and we're using a SIM, .3, and another vendor's using a SIM .4. There's that commonality that's being used by everybody. So we get the interoperability. It's dynamic. It's not static any longer. The speed of data flow into the network operation, the speed of usage, the speed of analytics is all increasing. That's all accelerating as we get towards net zero. The whole SIMification, if that's a thing which we made up, grid data and model for interoperability. Everything must have a SIM flavor. Everything must be compatible with the SIM model, whatever we call it in your system of record, whether that's your geospatial system or your real-time network model or your PSSE planning model, or I know other products are available, then that terminology, the description of the switch or the transformer or the disconnector has to be consistent across all those applications, so the data can transfer electronically, minimal human input, and also speed up the process. And also looking at data model as a service, really. How do we make the data model accessible outside of the individual network operators, so that market participants, new people who want to do network studies, even if it's building a new development, might have an independent network operator who needs information. Their need is different to a solar farm or a wind farm who wishes to connect. So that's the approach we see. That's the sort of challenges, and why we're very supportive of the approach of what we're doing with the grid data model. When we talk to customers, some of the challenges we have in meeting this. I mean, this is a journey. This isn't really a destination. This is a journey we're all going through, and it will take time to get there. It will take time to get convergence. But the data accuracy that exists within the business, the data completeness that within the enterprise, both of those need to be better. It's all very well thinking we've got a good data set, we've got a complete data set, but as we start to use it more actively across different business processes, it's really important that those two elements are given attention. I'm not proposing that we do a big data collection exercise and it's going to take 10 years and we're going to collect every data point. With this techniques and analytics, we can build that up progressively, but it's important that they're focused on. Where does that feed into the network model? And I put model black brackets S because there are multiple network models. There's the the design model, the planning model, normally the as-built model, and then there's the real-time operational model. It's feeding the data that's compatible with all those models. And how do the users need to use the data? A planning user needs a lot more flexibility in simulating what the system will look like in 5-6 years time than an operator who's looking 24 hours a week ahead. Their user requirements are different, so the data is required. Having a definition of the master version of the truth. It doesn't have to be a single point, everything has to be there, but you need to be able to point to where that master version's held. And also, how do you update it? And I mean, Pat touched on this in the last presentation, you need to get timely updates from when things have changed on the network, whether that's a new connection, an uprated connection, you've done a maintenance which has reset certain characteristics. You need to get that data back in quickly. So there needs to be processes that support timely updates. We need data mastery. We need processes that define what data is, what data means, how we name data, how that flows through, and somewhere some reference of library we can point to where within the enterprise we can say this is where we master our data, this is how we define our data. When we name a new item, whether that's a storage device or it's a generation device, this is the nomenclature we use, and we use that consistently across all the applications. And then we get to the interoperability. That's all those steps, and it's shown here as a linear flow. Clearly, it is not linear. It jumps back and forth. We do things in different sequences. We get updates at different times. So PowerPoint shows it as a nice linear. I appreciate it's a lot more complex than this, but we now get to a point of interoperability and open data across the enterprise and beyond. So we're now into a world where within the enterprise, we've got a set of open data which can be used in all timescales, and then we've got a set of data that we can open up to the wider community who are using the energy system. So the way we see this, we've got sort of three layers. We've got the sort of network management system, distributed energy resource management. DAX is our digital twinning application, asset management, advanced management and analytics, and all the aggregation services that take part in operating the network day to day. And at the top, we've got all the users who want to have access to the network model. They either want to connect, they want to maintain, they want to extend their connection or decommission a bit of equipment. They want access to the network model, they want planning tools, they want consistent data, and they want to make quite often big financial decisions based on the accuracy of the network model. And what we're proposing as Oracle is this layer, and we're showing it in the cloud, and the cloud, I know people may be horrified by that, the fact that we're proposing putting network data and some personal data into a cloud, but it would be secure. But it gives the ability then to do a model data exchange between all these communities of users. Certainly we can do the wraparound of GDPR, all the confidentiality, but then you've got a platform for not only planning in the longer term, where people are looking for network data, but also the ability for new connectees. An example we use quite frequently is a consumer. They bought an electric vehicle. They want to participate in a demand management program. How do they actually do that? How do they participate? How do they bid that device in? If you've got residential solar or residential storage, how do you participate in the market? How do we encourage more participation? And certainly I'm very much of the view that without customer engagement, we're never going to hit the 2030, 2050 net zero targets. We need a way to make it easier for end customers to engage in the market, whilst at the same time, the network companies, distribution and transmission, maintaining stability, maintaining the quality of supply, continuity, security, all the things that they do today. And then in addition to, they're now taking on the responsibility of becoming a distribution system operator and all the new functions that entails. And just as an example, using the work that we've done with the EPRI and the SIM GDM function, like in just a DERM, just one module that we're talking about. We need a mechanism where we can bring together forecasting, not just weather forecasting, but the forecast that's being provided by the market participant, how they bid, how that device is dispatched, how you schedule it, how you identify optimization on the network day ahead, week ahead, year ahead. So you're not constraining off low carbon technology. You're actually making the maximum utilization of the network that's available, and then identifying investment decisions. Because obviously, as you see the capacity on the network reducing, you can make better investment decisions, which all delivers efficiency to everybody. The whole energy sector becomes more efficient. And then we've got reporting. How do you report back? Clearly, if it's a cloud service, it's fully scalable. It doesn't matter whether there's 100 users in the cloud or 1 million users in the cloud. they're all accessible, you know, and you can run reports on why did somebody run, why didn't they run, where the network violations were, you know, what as a network operator is being done to alleviate those things. And there's a whole list of other things as well, which we're envisaging we will use the grid data model for, in terms of exchanging data in a consistent and accurate way. The way we bring that sort of together is we look at things like the model itself. We use analytics. We're looking at validation between what people bid in as their theoretical availability, their theoretical output, and what really happens. And then we can use machine learning and artificial intelligence, and we can improve our forecasting. So if somebody's consistently bidding in, we will offer 10 you know, kVA of generation, or they'll offer, you know, 500 kVA of demand side management, and you're consistently not getting that as a service. Then using the analytics, using the you know, the real-time data that's coming in, and that consistent data model as the core, we can then start looking at forecasting, you know, not just in the short term, but in the longer term, you know, year ahead, to make more valid decisions. But the core of that is having the confidence that your network model is accurate. And when we're talking about putting more at the edge of the grid rather than having everything centralized, that information can transfer consistently, quickly, accurately, and any updates which are coming through are, you know, validated either electronically. Technology exists to do that, or it goes to a person and they validate the network change, and then that suddenly becomes through, and then that's managed as a full audit trail. We're also taking advantage of the technologies which have already been invested in. So the advanced metering infrastructure, metadata management, access to information that, and I know there's a lot of people from different market structures on the call, but obviously here, you know, locally where I'm based in the UK, where the retailer owns the meter, you know, typically the model would be the network operator owns the meter, so they have more access to the data. You can bring the data in anonymized, you can aggregate that onto the low voltage network, and then start doing more granular analysis of your network all the way down. We're not suggesting we get rid of traditional SCADA. That's going to be there. That's going to be the core of your power flow engine, your automation, how you decide where to dispatch, where you can connect new generation. And that's a really rich source of information, which you can, with using the common data model, you can now share further upstream in the business process. So rather than just containing SCADA and historian data within the control environment, because you're now using a consistent data model with consistent terminology and interoperability, you can actually move that data, you know, further up the business. And obviously you can bring in third-party applications. So that's the way we see the process of using the grid data model. In sort of the example I've used here is sort of distributed energy resource. We could use that for asset management. We could use it for transformer loadings. We can use it for interoperability between the distribution network operator, the ESO at the transmission. Where we've had point-to-point solutions between distribution and transmission, typically ICCP, I think as the world moves to more distributed generation, there needs to be a more open data exchange beyond the point-to-point. And I think with, you know, our thinking around how we can do that securely in the cloud, and the ability to use a consistent model language and a consistent model structure, allows that richer data exchange to take place between the transmission operator and the distribution system operator. So these are the opportunities that we're seeing being unlocked by the project. The other thing that we're seeing more and more is the whole, you know, distributed control. We still have the central network management system, distributed energy resource management system. That would be your sort of master real-time operational model. but then putting more and more intelligence in these edge devices. So you have an edge device which can respond really quickly. It can respond to your solar battery in a local area. So that really sub-second response that you need, either for frequency response or for stability, we get at the edge, but you've still got the overriding optimization taking place in the center. As say there's an unplanned outage on the network model updates in real time, you can export that directly to the edge device, so the edge is getting the same model, same visibility, same view as you're getting in your centralized network management platform. So that speed of transfer, the accuracy of transfer, the validity of the outcome all improves, because if you've reswitched the network, and that can be largely automated these days. Most of our customers use network automation as a way to restore customers as quickly as possible. They were mostly designed in a world of restoring customers meant restoring demand customers, but now we're moving into a world of we're restoring demand customers and market participants. So you need an automation that can do both. So we need the ability to, at the edge, operate really quickly, optimize these local nodes, these local controllers, and then the centralized authority, which delivers the set point, holds the data model, but allows that speed of response, that more accurate data exchange to take place in real time. Where we've done this so far, we've done this with a couple of customers, Electricity Supply Board and Northern Ireland Electricity here in Europe, SDG&E over in the United States, and a number of other participants, which we started back in November 2020. And we've done some interoperability tests already. We're showing how we can integrate Oracle Distributed Energy Resource Management with another vendor's network management system by using the generalized grid data model. The ability to extend data out from the real-time model into other systems. So we can extend out into the asset management system, into the geospatial system. Sorry, I've gone a slide too quickly. Into your customer care system. So when there has been an unplanned shutdown, you know where those customers are connected on the network. If it's a smart meter alert or somebody calling in on the telephone, you can immediately give the customer better information, because you've got high confidence in the accuracy of your model. And just to prove this is real, as we update our new network management system, every new release, we're making sure it's consistent with the SIM release that is part of the GMDM project. So we're keeping track so that we don't get that divergence and get into a world in 2 or 3 years' time where we all started off with the same SIM version, we all started off with the same data exchange capability, but over time that gets weaker, because as each vendor updates their systems, that SIM model becomes out of date. There's more information at the link on the web page, which we will share after the event. And then just one thing I'd like to emphasize, and I'm not going to even discuss the diagram on the right hand side of the page, but that's the complexity of what we're going to do. But on this June event, June 14th to the 16th, we're going to run a full interoperability test. We're going to get 10 distribution vendors involved. We're going to look at data exchange models. Can we exchange between distribution and transmission? Can we exchange data between grid planning and operations? How do we bring data in from the GIS system, and how does that translate into a full real-time connectivity model? Is the data as described in the one system compatible? So as we start looking at things like feeders and substations, we know that they're a linear asset. They go from A to B. Are they described the same? Do they have the same electrical characteristics, the same length and the same type? And just making sure that all works together. and that will be the proof of the sort of pudding, as they like to say. So this is taking place 14th to the 16th of June. There's links for people who want to register. I'll let Pat explain, because I'm not sure whether it's an in-person event or completely virtual. Pat, I'm sure, will answer that in a second. But yeah, there's more information here for people who are leading that event. So anybody who thinks this is just a nice theoretical piece of work that EPRI have been commissioned to do, we're actually putting it to the test. I mean, Oracle have just one of the number of vendors who have been involved in the project, so we're fully supportive of this approach, as are the other vendors who've been involved, because we recognise the importance of, network operators don't want vendor lock-in. That is quite clear. That is uncompetitive. It slows net zero down. It slows down the whole openness that we're trying to achieve by using this interoperability and the data model. So please register for the June event. I'm sure it's going to be interesting. It's going to be live. Things will go wrong. I think we can guarantee that, but we'll learn an awful lot from that event. So in the time I've got, that's all I wanted to sort of say. So if there's any questions, I've not been able to monitor the chat while I was talking, but any questions that come in, I can take, or we can, Pat, if you'd like to take back control of the screen, that'd be great. And thank you for the time.
Danny, you might have to speak up and ask your own question.
Yeah, hello.
Hello.
Hi. I just like to, perhaps it's a blunt question, but what's your opinion on an open source concept approach, which possibly provides the best set of joint innovative forces, I would say so, to enable speedy development of new functionality without breaching competition rules? You mentioned some part of vendor locking and things like that. Could you say something about this?
I've seen the open source approach. I think one of the concerns the vendor communities share is on the longevity of how you maintain that integrity over a long period of time. I mean, as vendors, we provide systems, we provide the support, the updates, any integration points are all supported within the vendor model of the way that we deliver. I'll just talk about network management systems. That's the main sort of mission critical application. My concern with open source is twofold. One is about how you maintain the accuracy over time and the supportability, but also one of the concerns I do have is around security, cyber security, because with open source, clearly there needs to be a process of how you permit open source applications to be commissioned into what are environments mandated for critical national infrastructure. And once you start doing that, I think there is a cybersecurity question which I've not seen fully answered. I'm not saying it's out there, but I have not seen the cybersecurity aspect of open source completely answered. And I think there's a question for regulators and security services on how we maintain a secure environment for network operations, without diluting the level of security and integrity that we already have. Now, we can do that in other ways. I mean, we can do that, as I've tried to articulate, using a cloud, where we can actually put a lot of the information in a secure cloud environment with, permitted login and firewalling and all the good things that you'd expect us to do. But open source, I'm yet to be convinced that is actually going to give the same answer that you would get from buying a product from a vendor or a number of vendors to get the same solution.
Thank you very much for your answer, David.
Okay, thank you. Sorry, Pat. I think I've overrun it a little bit, so it's probably squeezed the last few minutes in the wrap up session. So apologies for that.
Mute, Pat.
Pat, are you there? Or are you still having comms problems?
Actually, David, if you could still maybe just give your opinion on the MRID problem, the syncing of IDs, like, you know, if you need to put power system models back together again, then they have to stay the same for incremental updates as new substations and things change.
Yeah, absolutely. Yeah, it's a really interesting question, and it depends whether you're talking to a transmission operator or distribution. Transmission,
Potentially all of them. That's the
yeah,
problem.
potentially,
So
absolutely.
multiple companies, like the NSOE level of problem, but maybe just a bit smaller.
Yeah, completely. Yeah, and I think a transmission, there already is a lot of data which has been through that cleansing process. You know, there's been a lot of data which has been used, you know, for a number of years for power flow studies, stability studies, you know, all the good things that transmission operators need to do. So I think they're starting from a much more advanced position. As the distribution operators go through that same journey, what we're trying to do is, rather than rely on human collecting data and validating data and maintaining the model, is apply analytics, you know, machine learning and AI to the data which already exists and spot anomalies in the data set. So when we do a power flow, largely we work with distribution system operators, but when they do a power flow using the state estimation techniques and comparing the SCADA data against the power flow data against the data model, we're able to spot anomalies in either the data consistency, the data accuracy, or the data completeness, in fact, and then point our customer to go and look at this circuit, because you know that you've got 3 points of reference. One is your static model. You've got SCADA data, which is coming in real time, and then we've run a power flow on your network connectivity, and you're getting 3 different answers. There's clearly something wrong with the data in this area, and then but rather than do that as a manual process, we're applying analytics to the problem, and also, you know, things like spotting, you know, where new low carbon devices are connected to the network. You know, we're using analytics for where people have connected EVs or solar and not told their local network operator. You know, where metering data is attributed to the wrong phase when you get down to the low voltage. We're applying analytics to those as a technique to improve the network model incrementally, but as quick as we can safely, so we don't lose all the work that's been done to date in terms of pulling data sets together and trying to make it easier for our customers to manage data across their business, manage that data flow, and at the same time get better data, more sustainable data. But I think Pat used the expression earlier, sort of where the rubber meets the road is that interface between transmission system operation and distribution system operation. That's going to get a lot more complex over the next 10 years. And that data exchange, the openness of the data exchange, the visibility into respective networks is going to be one of the big challenges is probably the wrong word, big opportunities for us to actually really drive forward net zero by engaging distribution more and more in active operations. So we see it as a journey, not a big one-off data collection exercise. It's something you do over time, but we've got tools and techniques today which can actually assist in smoothing that process.
I think if you guys can hear me, we got our audio issues straightened out on this end. I apologize, and thanks to Karen and David for kind of filling in for me while I wasn't there. I just want to, we just have a few minutes left. I did want to weigh in briefly on the open source question. And, you know, that is a, what's the right word? Important, weighty, multifaceted question that clearly is an important one. I would just point out that from the perspective, though, of managing the data inside of your utility, you still need a good design, and you still need to leverage standards for those data exchanges. And you know, as I was sort of scanning through the participants in our interoperability event, we have either one or two open source based vendors that are participating. So important topic, but it kind of doesn't obviate much of the need to do all of the other important things that you need to do as a utility for managing data, I think. All right. I just wanted to share a couple of things with you. For me, the key takeaways from today really have to do with the fact that we should kind of all be grateful to the folks that are actually outlining external entities that need information sharing and doing so in a SIM format, because that drives a set of requirements that are SIM-based for interfaces. I would say that it's important to remember that those data exchange standards are essential, and as essential as those are, so is a good architecture or a good design that actually allows you to do that single source of truth data management. And yeah, we got stakeholders all over the place, so it really does require a lot of them pulling together. I just wanted to share with you, and this deck will be posted and these links will be available to you. There's a Grid Model Data Management public-facing website that's got lots of information on our Grid Model Data Management and distribution activities. There's a couple of old transmission reports that are still valuable. They will be being replaced by distribution reports that will be publicly available once we get through the IOP. We wanted to make sure to incorporate the knowledge from the IOP into them. And then lastly, there are a couple of ways that a utility could directly engage with some of these EPRI activities. The first of them, as David mentioned, is our IOP. You could sign up and be a test witness. It is not, hopefully, virtual. We hope it's in person at the Charlotte facilities in North Carolina. And there's information on how you could sign up there at the bottom. It will be, again, in the deck that's posted. And lastly, we are still doing deep dives with utilities to really look at their as is, to help them identify strengths and weaknesses, to develop a vision, probably identify some no regrets kinds of actions. Anyway, all of that is an option, and we'll get the decks posted for you. Thanks so much for choosing to spend a couple of hours of your day with us here talking about grid model management. Cheers.